So this question here says, a fat man of mass 90 kilogram is traveling in his sports car of mass 1,260 kilograms at a constant velocity of 30 meters per second. He is signaled to stop by a police and immediately applies the brake before coming to a stop in 6 seconds. Now, the first thing they want us to do is they want us to calculate the average velocity of the car from the time the driver applies the brake to when the car came to a complete stop. So, to work this, we're going to consider the formula for the average velocity, where we say that the average velocity, V average, is equal to the final velocity plus the initial velocity divided by 2. So in this case now, because he was traveling at 30 meters per second and he applies the brakes and came to a stop, what we're going to see is that his final velocity when he would have come to a stop would be 0 meter per second, and his initial velocity would be 30 meters per second. So we're going to add these two together, per second, and divide by 2. So when we work this out, we're going to see that we're going to get 30 meters per second divided by 2, which works out to be 15 meters per second. So its average velocity would be 15 meters per second. So let's see what's next. So next it says now we're to determine how far the car traveled from the instant the brake was applied to when the car completely stopped. So we can take our expression where we say that V is equal to the displacement over time. Now in this case, we're going to be using the average velocity for V, and we're going to solve for the displacement S, which would be the distance he would have traveled right from when he applied the brake to when he actually came to a stop. So we're going to transpose to make S the subject. When we do so, we're going to get S is equal to the velocity multiplied by time. And again, in this case, we're going to be using the average velocity. So we're going to get the average velocity here is 15. So we say 15 meters per second multiplied by the time, which is 6 seconds. Right? When you multiply these two, 15 times 6, we're going to get, let's take the calculator just to verify. We're going to say 15 multiplied by 6, and we get an answer of 90 meters. So what it means is that he would have stopped 90 meters from the moment when he applied the brake to when the car actually eventually came to a stop. So let's see what's next. So next thing now, they say we're to calculate the deceleration of the car. So we know by deceleration, because the car was slowing down, we can calculate its deceleration. Now, the deceleration is the same thing as the acceleration, but because the car is slowing down, we refer to that as a deceleration. So we say acceleration, which is the same as the deceleration, is equal to the final velocity minus the initial velocity divided by the time t. So in this case now, our final velocity would be 0 meters per second, and our initial velocity, right, would be the velocity when the brake was applied, which was 30 meters per second. So we say 30 meters per second, and we're going to divide by the time taken for the car to stop, which was 6 seconds. So what we're going to get then now is we're going to get 0 minus 30 is going to be minus 30 meters per second divided by 6 seconds. When we do the math right here, we're going to get minus 5 meters per second. And in this case, we get a negative value for the acceleration because the object was decelerating. Now, let's see what's next. So next, they say we're to determine the braking force applied by the brakes on the car. So to do that, we're going to consider that the force, braking force F, will be given by the mass multiplied by the acceleration. In this case, is going to be the deceleration. Now, we know that the mass of the man was given as 90 kilograms and the mass of the car was given as 1,260. So the mass M will simply be equal to 90 kilograms plus 1,260 kilograms, which when we add these two together, we're going to get 1,350 kilograms. Right? And in this case, the deceleration will be 5 meters per second squared. All right? It should be meters per second squared. All right. So now we can now calculate the force. So we're going to say now 1,350 kilograms multiplied by 5 meters per second squared. Right? When we calculate this, let's get the calculator. So we say 1,350 multiplied by 5, and this gives us an answer of 6,750 newtons. Now in this case, we did not use the negative value because we know that it's going to be a force acting against the car to cause the car to stop, right? So we get 6,750 newtons as the braking force. So if there was anything in this question that you wish to get further clarification on, you can post it in the comments, and I'll do my best to clear up any misconceptions for you. Like this if it was helpful. Click subscribe and the bell so you're notified whenever new videos are available. Thank you for watching.